Friends, I'm highly grateful to the organizers for having provided me this opportunity to be here today. Um, and then all along this 36 years I had been in ICR, and then I ended up being the member of Agricultural Scientist Recruitment Board. And so that way, and as an ADG in plant protection, I have been privileged to go around all over the country and representing India in delegations of Codex Committee on Contaminants and Pesticide Residues and Contaminants in Food. I think we need to. Okay. Okay. I'll request my co-chairs to kindly indicate me about the time so that I should be maintaining, and all of us will be maintaining the given 20 minutes, trying to do that. So, aflatoxin has been a very big problem now in the trade, and it's not that aflatoxin is Chilli is one of the most important problem. This is a group of substances, we can say. This is a group of mycotoxins which are there, and is fumonicomerins group, and highly neurotoxic in nature, class 1 carcinogenic in nature, and they are having the major concerns, and they are caused by two major fungus or species of fungus, Aspergillus flavus and Aspergillus parasiticus. Parasiticus means there are other Aspergillus groups also, or other species also, but these two are the parasitic ones. Others are mostly saprophytic ones, and these two are responsible for the mycotoxin production, which is aflatoxin. There are many of you will be knowing that aflatoxin B1, B2, which are under UV light, they will be looking as a blue color, and G1, G2, which are greenish in nature, color. So B1 is the most potential of the neurotoxicants, and that is a matter of concern. And what is the significance of the toxicity? So this is because we have all along we have been dealing with the production, productivity and all those things. But then post-harvest, India is the highest producer of spices in the world, and this year was a 12 million ton worth of spices India produced, and we have spices export worth 4,000 million US dollar all over the country. And India is known to produce all the spices, maybe 97 of 127 spices, and because this is India is it's awesomely endowed with natural agroecological specificity in different parts of the same country, which provides all the habitats for different kinds of spices. Nowhere in the world such number of spices can be seen there. So if you see, around 25% of the world's of food is affected with this aflatoxin, and out of which these are those which are found improperly stored crops, and chili pepper is one of the major crop which are having this aflatoxin production. Those we are producing, we are in the research, we are in the production, we do not know much, or we do not hear much about the toxicity and toxicity program and this trade barrier which is happening, because whatever we are producing, farmers are getting the money and all, but the export is another problem. Every year I will show you how the export consignments are being rejected because of one small word called aflatoxin. And these aflatoxin contamination, they occur both during pre-harvest phase as well as the post-harvest phases. And so this is the health impact. Most of I don't need to say, but then they cause liver cancer, and they belong to group 1. Even the pesticides are not that toxic in nature. No pesticide can be used as a member of pesticide. No chemical can be used as a member of pesticide group if they fall under this group 1 of carcinogen, whereas this aflatoxin is a group 1 carcinogen. And these are the various other co-indications and after indications which are being caused by this. And what are the high-risk crops? There are plenty, as I said, 25% of all crops which are there, they are prone to aflatoxin infestation. And spices, chili pepper, black pepper, turmeric, and all, there are so many others are there. I have not listed all of them, but these are high-risk crops which are most vulnerable to aflatoxin production. Factors that produce, because we produce and thereafter we tend to lose what is happening in the yard, in the drying yard and all those places where, and so cotton mission has been there. So cotton mission, government has for 2 times government it invoked mission on cotton just to make the healthy harvest and healthy how the after production, how the post-harvest cotton are free from any kind of contaminants, which are the biggest problem in that. So in this case, in the coming event, we must also take into regulatory practices how to have a mission on chili, where government should make provisions for clean harvest also. And there were TMC 1, Technology Mission on Cotton 1 and Technology Mission on Cotton 2, that was dedicated to clean harvest. Whereas yards, the cotton yards and all those things were cemented, platformed, so that hair contamination, all those things should not go there. So that kind of sanitization and phytosanitary needs requirements will be required. And when we are going to make any regulatory recommendation, we must enter into the thing that technology mission on chili should also compare and cover those kind of aspects for clean harvest. So pests and diseases which are initiated in the infected fruits, like in case of black thrip or any kind of thrips or whiteflies which makes a sooty blotch kind of thing, they are the attractants for those fungi which causes aflatoxin production. So right from any of these biotic or abiotic stresses, those are the predisposing factors of aflatoxin production. And chili, I need not tell, but then what is the importance, widely used globally as a spice, condiment, flavor, enhancer, color agent. And these have all the medicinal properties. They have a very good deal of antioxidant properties. And outside the world, I weaned even many Americans into taking chili. I was in the US for 6 years, and whenever I used to go, our flavors, I'm very fond of non-vegetarian and all those things. So we used to cook, it used to smell very good. So my advisor would come and then he will say, something is smelling very good. So he will come, and when I'm having my lunch, I'll have my own home cooked something, and then they will be fascinated, and he will be coming to my laboratory at that time only. And the moment I will open my container, he will say, no, it's very spicy. So I said, you people are misguided by spicy. What do you mean by spicy? Spices are all medicinal. If you are thinking chili is the only one which is hot and that makes everything spicy, you think. Subsequently, I weaned him into that without spice, to different level of spice I weaned. And there was a time when he said, unless you cook food for me at home or call me for food, Indian cooked food, I will not come. So that was the importance of these chilies and spices and I am still very fond of eating chili. Today also at lunch I had three chilies, long one. So this is the aflatoxin contamination. I said that these 2 species are the main infestation which are causing the problem, whereas A. niger is also there, which is also causing aflatoxin production, mycotoxin production, but it is producing ochromycin, which is not as fatal or as carcinogenic as aflatoxin B1. This is also, but it adds to the total aflatoxin production, and which also has a ml level in case of Codex Committee, and in India also has its own the limit on that. So major factors are unripe and damaged fruits stored under damp conditions. So India's contribution, if you see, world's largest producer and consumers of so 40% of global chili production is contributed by India, and 40% of our all exports also. We export $4,000 million US dollar worth of export. We earn through that, out of which nearly 1,500 is 40% of our foreign exchange, which is earned through spices, are coming from only chilies export. And these are the major countries which are there, and ensuring safety from aflatoxin production is critical for domestic consumption as well as export market. So it is not that we need to only for export potential export, we need to organize our market or sector, but we have to also ensure the safety of our human domestic consumers also. So we need to see that too. So these are the export rejection data of chili due to aflatoxin. Recently in 2024, Netherlands and Germany, they exported, they banned our consignment of chili powder which was there, and there was a border rejection of aflatoxin because of the contamination of aflatoxin B1. 2023 spice exports, EFSA, which is RASSFF. So that is this particular body of European Food Safety Association. They made notification due to aflatoxin contamination in Indian chilies. Chili powder, again aflatoxin contamination, because the limit is 5 microgram, whereas 5 microgram per kg is 5 ppb is the limit, but we had 13 microgram per ppb. So that was the rejection reason. And from 2010 to 2020, there were 224 notifications which were from India due to aflatoxin, chili aflatoxin, out of which 180 from India only, 224 from other parts of the country also. And there has been a continuous contamination and rejections of our consignments due to aflatoxin production. So Codex Committee on Contaminant in Food, and so that is the nodal body, World Codex Alimentarius body, which is, and CCCF is Codex Committee on Contaminants in Food, which is a body, is an organization of WHO and FAO, which represents Codex Committee, and they are the ones which are fixing the value of ml level, means at or maximum level limit of this contaminants in the food. So what they do, CCCF, they set the global safety limit. It's a global safety. Any country which do not have the facility of regulation or regulating this codex or the calculation, determination of ml level, we have, India has one of the stringent law where Food Safety Standards Authority of India is, and the Ministry of Commerce, they both are involved into that, and Nodal Codex Committee is associated with determination of limits of contaminants in the food due to various contaminants, and that too on risk analysis basis. Although no contaminants are allowed at any time, but then for the geogenic nature, if something is happening in the nature which cannot be controlled, it is the limit is fixed based on the risk assessment basis, that how much can be chronically fed if it is fed to the mammal. So continuously for 3 months the amount is fed to it, and subsequently food factor and all those factors, and finally a limit comes which is then divided by 100 where no abnormality is detected. Means this is fed for 3 months to a mammal where at a fixed amount, and then that amount they calculate the NOEL, which is no observed adversity effect level. Up to that level they will go, and if no abnormality is detected up to say 5 ppb, then it will be divided by 100, and then that will be fixed as a ml level. 0.005 will be the ppb for that. If 5 ppb is the no observed adversity effect level, then that is further divided by 100 and then it comes to be 0.05 ppb is fixed as the ml for that particular contaminant. So there has to be a multifaceted approach to bring down the ml levels to through pre-harvest and post-harvest and processing strategies and prevention approaches. So and that was Codex Committee on Contaminants in Food, whereas FSSAI, it comes at our national level. That was the international level, because any country which do not have their adequate facility to detect or determine the ml levels of a contaminant, they can depend upon codex values which are fixed. But over and above many countries, because India is signatory to the Codex Committee, and there are 180 countries in the world which are signatory to that, and any country over and above Codex level, India makes its own ml level. Some of the ml level which is fixed or limits which are fixed by India is stricter than even the Codex level. Like in case of dicophol pesticide Codex Committee, India has 20 ppm as allowance, whereas India has 5 ppm of dicophol can be allowed in tea, whereas 20 ppm is allowed by European Union. So it is not that Codex values are very strict always. It is Indian values are also very strict, sometimes more stricter than Codex. And in such kind of cases, our industry, they face a difficult problem when they say when European Union is wanting up to 20 ppm, why do you insist us to make into 5 ppm? But then India has its own stringent law and we follow, we respect our own law. So FSSAI, it fixes the maximum permissible limit in the food based on its own data, because our food factor is different. All over the world, WHO has, they categorize all the different kinds of food into 17 GEMS food cluster, of which India belongs to GEMS food cluster 5. Whereas in the US and all, those, they belong to GEMS food cluster 16 or 17. So their food habit is different. India fixes its own ml based on the Indian GEMS food cluster level. So on that basis, sometimes we are more strict on certain things. And monitoring surveys conduct, we have to, FSSAI conducts nationwide surveys to check the aflatoxin contamination. Then publishes manual with the standardized and validated methods for analysis, and to state regarding contamination and call for proper. In case India is one of the party to the fixation of arsenic in rice. You know, in the world, Codex Committee had fixed arsenic contamination of rice with the arsenic to the level of 200 microgram. But in India, it contested there. After going to Codex Committee, they said, no, in our parts of the country, we produce rice, similarly any spice, and we are, those arsenic, nobody adds to the soil. It is geogenic in nature. It is nature is adding to it. So we cannot go there and we cannot reduce that. So they say, okay, on that basis, Japan was the EWG chair, Electronic Working Group chair, and they included India, and India could give 500 data points to them and show that our overall arsenic content is up to 3 microgram, and those risk assessment was done by Codex on 300 microgram. Microgram is 300 ppb, not ppm of arsenic, and it was found to be safe for consumption of human, because anything which we use, the contamination is seen on the raw material, but whatever eatable part is, husk is removed, and then it is polished, then rice is boiled, lot of contaminants, they die. So in that case, India could escalate the limit of our ml level of arsenic to 300 from 200 ppb. Similarly, any such kind of risk which are coming, India is also going there in the Codex Committee, and we are defending our case and then judiciously coming out in raising, because other countries, they do not produce. They have enough money to import, but India is the one which produces, so it is always we have to do our own work. See, these are we say SPS based ML levels. Why SPS? Despite Codex Alimentary is, they propose a total aflatoxin is 20, but over and above European Union, you can see, they have fixed 10. Although European Union is a part of Codex Committee, but they say no, for our country we want only 10 ppb. So different countries have different allowances of this limits of toxicants, and India, based on it, it has made 30 ppb. 30 ppb is there, and finally in case of Chilli, 20 is proposed, and it is being debated. It is debated over the years, and so thereafter from 10 ppb of European Union, it has been coming down to narrowing down to 20 ppb, which is not yet approved. It will still go and it will be debated in 2-3 years, and finally the amount which is still beyond or below the risk limit, that will be fixed. And from European Union aflatoxin 5 they kept, but total aflatoxin we are seeing, and we are not letting it over the 20 ppb to meet our trade export requirement. So approaches for management of aflatoxin, if you see, so now I had been discussing with some of the scientists and researchers here, and then we found out the research has come up where they have found that certain genotypes are aflatoxin resistant. They impart tolerance to aflatoxin accumulation. So that kind of breeding has to be initiated under the academia. Then adoption of good agriculture practice, we say, this is a mere say, but then we need to follow in the mission which will be requested for. There we will ask for good agriculture practices, including post-harvest process. Early harvesting can reduce the risk, because older they get, the infection they harbor becomes more problematic. Field sanitation, proper drying and storage, sorting and inspection and monitoring. So these are very much required for heat treatment. This has been found to be very effective in managing reducing the amount of, or the residue of toxin or this aflatoxin. Chemical treatment means even this include even inhibitors of aflatoxin chemical, as well as inhibitors of certain pesticides also, which we use from the beginning, so that aspergillus infection does not take. X-ray treatment, closed cold plasma treatment, Codex has approved 3 different kind of treatment: X-ray treatment, gamma irradiation, and because many of the countries, they will not accept all of them. Cold plasma treatment, many of the countries, they do not accept, but these 3 treatments and electron beam, those 3 treatments have been approved by Codex for the treatment and reduction of aflatoxin. If you go and heat it, if you go for sun drying, Codex does not accept that. Codex does not accept, or neither it recommends for sun drying of chili for aflatoxin prevention. It says only 3. Now, of late, biological treatment employing probiotics and other beneficial microorganisms have come, and these are being used. In case of Grape Institute, recently one of the scientists have found one species of bacillus which is very potent disintegrator of pesticide. Means post-harvest, that bacillus species is sprayed and the grape surface is being cleared. I think that is the last slide. So these are the regulatory measures which we need to emphasize and which we need to strictly include into the regulatory realms which we think of now converging into in the subsequent meetings as a recommendation. Development and implementation of effective sampling and testing programs. This we need to have because one cannot go to see every lot. We have to do some kind of sampling. For pesticide also we are lacking that kind of problem. How to sample? There are 300 industries, they are manufacturing, and all the entire countries chemicals and all, they cannot be sampled. Similarly, this every sample which is being there. So sampling procedure is required for properly sampling those kind of analysis, setting maximum level for aflatoxin in food. This has to be done based on science, and we have our food technology institute. They are going into codex. Nowhere in the policy making our ICR institute comes, neither our the CMFI, what is this, CSR institute, CCMB, nobody comes there. There, when I went there, I thought in the ICR so much work is being done, but they are asking, does India have any data on that? Nobody is there to tell. I used to call there to IHR, do we have any, or to CCMB, or some Center for Cellular Molecular Biology and all those, CSR, Food Technology Institute, even Fisheries Institute for some kind of toxic substances. They have, but they do not go and represent there. And then finally, what is the way forward is to integrated field to market management. Right from telling that we have produced is not sufficient. We need to see before harvesting whether there are any precursors of aflatoxin production in the harvested material. Training and awareness programs for exporters and farmers, they are equally important, which is very important. And R&D on aflatoxin resistant chili germplasm, this is one of the R&D based requirements which our academia can take care. Compliance with the codex and FSSAI standards ensures safe exports. That we need to do, because in days to come, we have now less than 1% of our produce are exported from horticultural sector, less than 1%. And our Honorable Prime Minister says it has to be 10% by 2030. So the moment it goes, we have every other pesticide means 85% of our crops have off-label use of pesticides. We need to see, and contaminants and all those things, we have to take care. And collaboration among farmers, processors, regulators and scientists is very vital in that case. So I think that's what I wanted to tell today. Thank you all for listening. Thank you.
My good friend, for having come all the way to present this wonderful topic. It's not we don't have expertise anywhere.
Yeah.
I would, one of the recommendations that should go is, this country somewhere should start work on an dedicated aflatoxin lab, because it's going to define our future of exports. And I don't know who does it, but somebody has to do it. We cannot say that in this country, nobody is there. This is something absolutely ridiculous. Second one is, in addition to what he said, we had a very peculiar problem. Cumin was exported. Identification of the toxin was a groundnut aflatoxin, because cumin was stored in groundnut bags. Cumin was perfect, but the storage was in groundnut bag. So likewise, chili may be grown. You may store it in some other bag. Yeah. Aflatoxin traces may be found. The Americans are so sensitive, they can tell which aflatoxin it is. So my request is, we have to raise to our scientific standards if we want. The third thing is, if you want really to have an export which is free of pesticide residue and free of aflatoxins and others, a method should come whereby residue-free farming absolutely without aflatoxin should come. Even if the yields are low, if their product is worthy of export, I think those kinds of package of practices must come. It is not always productivity, but money through export. If it is more by less yield, I think those kinds of things should be encouraged. His topic was excellent, and I'm very thankful to Dr. Chakravarthy.